Aloha and welcome. In this video, we're going to be talking about digital certificates, and I'll show you one towards the end of the lesson. So let's go ahead and open up our text, and we're looking at digital certificates, or what we call public key certificates. What are these? Well, they're an electronic document that's going to prove the ownership of a public key. So a digital certificate, it contains the certificate owner's public key and identity information, and that's going to include things like name, address, organization. So it's also only valid for a certain amount of time before it expires. So a certificate, it's digitally signed by a certificate issuer, what we call a certificate authority, a CA, and they're the ones that verify the content of the certificate, like who it's being assigned to and things like that. So the example they gave here is a digital certificate issued to Google includes the name of the certificate authority that issued the certificate, the issuer, the certificate's validity period, and the identity information on Google, and the public key that you'll use for it. And the public key part is important because, like, if we're talking about, for example, a website, the website has the certificate, you're going to need the public key. You're going to need that public key in order to do encrypted work with it. When you want to send your information to it and receive stuff, you're going to be using their public key to encrypt it, and they're going to decrypt it with the private key that they hold. So the private key is held by the certificate authority, or there's not the certificate authority, but the certificate owner. So we'll get to that in a few minutes. And here they have, I believe this looks like it's Windows. Is this Windows? You can take a look at the certificate authority and stuff like that. So in here, they're showing that the different attributes in here that you've got. So it has the like the name of the CA on the certificate. They've got the validity period. So they're going to step you through different aspects of the certificate, so you can take a look at that. And I'll show you one in a few minutes too. So only certificate's owner has the corresponding private key to the public key in the certificate. So as we said, you're going to be using the public key to encrypt everything that you're sending to that server. And at the server end, they're going to use the private key to decrypt. So the public key is the public key in a certificate is used, to securely communicate with them. So they have an example here as well. So we go ahead and click start. Key pair owner's public key and identity information is sent to the CA. So it goes that way. And then a certificate authority, the CA verifies the key pair owner's identity information. Then the CA computes the hash of key pair owner's public key and identity information. And then the CA digitally signs the key pair owner's certificate by encrypting the hash of key pair owner's public key and identity information with the CA's private key. Then the CA issues a key pair owner's digital certificate with a validity period. And that's the process of going ahead and registering your public key pair for use in something like a website. Moving along, we get to our digital certificate types. So there's many different types that are used. We've got the web server certificate, also known as a domain certificate or a TLS certificate. Again, it's called TLS because it's using transport layer security, which is where you get that. I don't think they use the little lock anymore in Google and Chrome, but they used to have a lock here, and that would signify that you're using security. Usually it's on port 443, and that's the transport layer security. So the TLS certificate. So anyway, that's the TLS certificate, the web certificate. This is a certificate that's used by a web server and a web client to establish a secure communication or a secure connection over the network. And there's four different types of web server certs here. So we've got a domain validation, a DV certificate, and that's only going to identify the domain's owner. It's only going to do the domain's owner. Then you've got the domain extended validation EV certificate. That's going to verify that the identity of a domain's owner, the domain owner's exclusive control over the domain, and the domain owner's legal and physical existence. So this is a higher level of security there. Then you've got wildcard certificate, and that's going to validate a domain and all the domain subdomains. So let's say you're doing development on, or you've got your own site, and let's say it's called hackers.com or something like that, and you want to develop applications that you have on subdomains of it. Like when we say a subdomain, a third level domain, let's say you're going to do you're gonna add on a domain or something like that, a subdomain. Whenever you do that, you're gonna have that also. You're gonna need a certificate for that, but you can use this wildcard certificate. It's gonna do everything. So if you had that hacker.com, everything within there is going to be considered covered by that certificate. So you'll be so the whole thing, the that whole site and all of its subdomains will be secure. It'll be covered by your certificate. Then we have the subject alternative name, the SAN certificate. And SAN is another acronym that gets overused a lot. SAN also stands for, I think, Storage Area Network, if you're in the hardware side of things. Don't worry about that, but here we're using it as a subject alternative name certificate. And that's used by multiple, when you've got multiple domains that are owned by the same domain owner. So if I own a multiple, like if I've got several sites for like underwater photography, uh, for like coding and things like that, I can get a, a certificate, a SAN certificate that's going to cover all of my domains. So this SAN certificate is also known as a Unified Communication Certificate, a UCC. And then moving on, we've got root certificates, explaining different types of digital certificates. So we've got a root certificate that's created and self-signed by a CA, a certificate authority. So a self-signed certificate is a certificate in which the certificate issuer and the subject are the same. So you're basically certifying yourself here. So a root certificate does not depend on a higher level authority for authentication, and the CA uses a root certificate to sign other certificates. So we also have the code signing certificate, and that's used by software developers or software publishers to digitally sign their software programs so that you know it's safe and it does come from this, who it says it comes from. So an installation program or an operating system, it's going to use code signing certificate to ensure that the program hasn't been modified or anything before they're installing it. So it's going to check and make sure that's actually valid before doing that. Then you've got email certificates. Email certificates are used to digitally sign your emails. An email sender encrypts an email with the sender's private key. The email recipient is going to decrypt the email using the public key that can be obtained in the sender's email certificate. So that's why we have the public key in these certificates so that people can do the encrypting. Then we've got machine certificates or computer certificates. These are issued to a hardware device such as a computer, router, printer, and these are used to authenticate a device onto a network. And we'll be taking a look at a certificate in just a minute, but first we need to go over the digital certificate format. So the X509 standard defines the format of a public key certificate. So the key certificate, or the X509 certificate, it consists of key value pairs, and a key represents a name and a value represents a number, string, or list. So we've got different formats that the X509 certificate can be in. There's going to be PEM, which is the privacy enhanced mail. We've got DIR, the distinguished encoding rules. We've got the PFX, the personal information exchange. We've got the two different ones, the PKCS number 7 and the PKCS number 12. So going back to the original one, we've got the privacy enhanced mail. It's in ASCII format. It's the only one that's in ASCII format here. The PEM, I call them PEM files, but PEM defines the method for encoding the binary binary dating, and it's using base64. So base64 is a binary to text encoding scheme that represents binary data in an ASCII string format. ASCII stands for American Standard Code for Information Interchange, I believe, and that is essentially it's a chart that shows you a correlation between like characters and their ASCII values. So ASCII values is going to be a value between 0 and the top number. I think it's 256 because we're talking about an ASCII. So in ASCII we're talking about characters, and characters, single character is 8 bits, so it's going to be 2 to the 8. So you've got 2 to the 8 different combinations here. ASCII covers what ASCII is essentially the mapping of those numbers to their characters, like A through Z, lowercase, A through Z, uppercase. But anyway, that's what we're talking about when we say ASCII. So the base64 is a binary to text encoding scheme that represents binary data in an ASCII format. So the file extension for this is going to be PEM. .pem, or it can be .crt or .cer, and that's going to get a little confusing because the next one we're talking about, distinguished encoding rules, also uses the .cer extension. So distinguished encoding rules, DIR, it's a binary format. It's a subset of the abstract syntax notation 1, ASN1, and that's platform independent encoding format. So the DER encoding ensures that the contents of a certificate can only be encoded in one way. So the file name extension for that is going to be either .der or .cer. Then we've got personal information exchange, PFX, and that's binary format as well. As I said, only one's ASCII, everything else here is binary. So PFX file is a password protected archive file format that contains the certificate and the corresponding private key. The PFX format is used by a server to import a certificate and private key from a single file. So the file name extension of a PFX is .pfx. So keep that in mind. PFX is used for the server to, and it's used there to import the certificate and the private key from a single file. So this makes it quite different from the previous two. So keep that distinction in mind. Then we've got the public key cryptography standards number 7 and number 12 binary formats. These formats define a standard syntax for storing encrypted and signed data. PKCS7 or PKCS number 12 is stored in a DER or PM ASCII formats. The file name extension of a PKCS number 7 file is .p7b, and the file name extension for PKCS number 12 is .p12. So that is something to bear in mind as well. And they have a nice demonstration of this over here. If you look through the participation activity, it's going to go through the X509 certificate and it's going to talk about the different types. So you've got ASCII, binary, and it goes ahead and shows you everything. So your PEM and these three extensions, that's going to give you the next one, which is the DER. So it's going to be DER and CER. And you'll need to know which extensions, deal with which encoding thing. It's DER, that's pretty easy, PM pretty easy, but you have to remember that CRT is exclusive to PM. CER is shared by both of these two. And then the last one they show is going to be the two public key cryptography standards here, P7b and P12. And that should be pretty easy to remember because you've got the number in the name, or the name, in the file format is similar there. So then moving on here, the last thing is the concept of key escrow. So key escrow refers to the secure storage and management of cryptographic keys by a trusted third party. So when you don't want to hold it yourself, you want an escrow agent. You want somebody outside to hold on to that, just to make sure nothing happens to it, but to provide access to it under special or special circumstances. And the examples they give are like for legal obligations. So instances of key compromise or secure key recovery. What happens if something happens to the key that you have and you need to recover it and you don't have it internally? You can, have it stored at an escrow agent who is going to manage these things for you. So key escrow is vital in environments where uninterrupted data availability enables lawful access and prevents the data loss due to misplaced or unavailable keys. So an escrow agent, just keep in mind, they're a trusted third party that are going to keep your cryptographic keys for you and give them to you when you need it, for legal reasons or for recovery reasons or times of compromise. And that is it, except now I want to show you something. I'm going to have to reshare this because I'm going to go up here to where to this place, and we're going to click on it. When we click on it, you can't see it, but it has a list here, and it's going to say learnzybooks.com. It's going to say connection to secure. Actually, let me go ahead and try to stop share and reshare that so I can show you what that looks like. This is going to be really difficult to do, but now you can see once I clicked on that thing, it's going to come up with this. I'm going to click over here on connection is secure, and then we can click on certificate is valid down here. And once we click on that, got to reshare my screen yet again because it's going to go to another place, and I need to reshare this screen with you. So this popped up, and this is going to give me information here on our certificate that we have for the site that we're visiting. So when we look here, these are some of the attributes that are with the certificate. We know that we've got the common name is it's going to be asterisk, which is a wildcard, zybooks.com. Organization ID, it's not part of the certificate. Organizational unit, not part of the certificate. Issued by, who's issuing it? It's Amazon. So Amazon is issuing this. The organization is Amazon. The common name is Amazon. RSA 2048, we're talking about obviously an encryption standard here, MD3. We've got organizational unit, not part of the certificate. Validity period, it's issued on this date, so December 10th of 2024, and it's going to expire on January 9th, 2026. So then it has the SHA-256 fingerprints. So SHA-256, remember we discussed that as well. We've got the certificate here, and we have the public key. So that's nice to know. We can click on details over here. Now we see the certificate hierarchy. So certificates are in a hierarchy there. So the root is going to be Amazon. So it's over here. You've got the root. And you can click on these, and you'll see that we have different information that pops up down below. So as we click through these, it's going to give us different information. So now we've got zybooks, the certificate fields. But if we look all the way up at the top, you can we click on things? Yeah, so you can look at like serial number, certificate, signature algorithm. So it's using SHA-256 with RSA encryption. Issuer is Amazon in the US even. So validity, not before. So it's got your dates in here and everything. So you can go through your certificate and look at different parts of it. But there's lots of neat things to see in here. So your public key, your certificate. So it's got all your information that you need to interact with that website. And that is that. So that covers the concept of digital certificates. Again, you want to look through there, and you're going to have to memorize some different things here, particularly the file formats. You need to understand, what is a digital certificate in general. You need to know what a certificate authority is. Remember, that's just the issuer that's going to say, hey, these people are who they say they are. They're going to have to do some verification on their own of that. There's different types of these certificates. You need to know the differences. You know that you have a domain validation certificate, domain extended validation certificate, wildcard certificate, and a subject alternative name certificate. So, or what they call unified communication certificate. Then you need to know that you've got different types of certificates. You've got the root, you've got the code signing one, you've got the email, and you've got the machine certificate, and you need to know what those do. And they're pretty self-explanatory in the way. Root certificates, again, they're created and used by the certificate authority. Code signing is for when you're, putting out code that you want to be trusted, so people know that it was actually from you. Email certificates done for, it's used for, sending emails back and forth. Machine certificate is good for authenticating devices to networks. Then last thing is the digital certificate formats. The X509 format, you're going to need to know the differences between PEM, DIR, PFX, and the PKCS 7 and 12. So you're going to have to remember that. And then just know what a key escrow is. Key escrow or an escrow agent. They're the trusted, you've probably heard the term, or maybe you haven't, but escrow agents in terms of escrow like financial transactions and things, often real estate. Basically, they're just trusted third parties that hold on to valuable things, and they're going to help you out should you have a problem with recovery, or your key has been compromised, or any number of things like that. So they just help you by keeping your keys safe. And that's it for this lesson. If you have any questions, feel free to reach out. I will see you in the next lesson. Aloha.